Good morning, everybody. Quite an early Saturday morning at 10:30. I know that I haven't done any live streams for a long time, so it's nice to get back to it. Morning, everybody. So, okay, today's lesson is for my Year 12s. Shout out to Pang, Pim, Lynn, Sibylla. So I'm doing chemical tests today. I'm going to try and box them all off as best I can. So today is going to be part one of this series. So I'm going to be focusing on organic tests this morning. Okay, now usually what I've done is I haven't done a live stream in a while. So what I usually do is have YouTube running in the background so I can check that the sound works. So I guess we'll just give it a moment because as I said, I haven't done this in a while. So let's see if I can get my channel up and see whether or not it's working. It's going to come out really loud. There we go. Okay, cool. It's all running. It also means that this is where I usually have the second screen to be able to look for the chat window, and I'm not going to be able to do it this morning. So, okay, guys, let's crack straight on. So what I want to do is I want to present, and I want to do share my screen with you guys. So let's do entire screen. It's always a good way of doing this. And then what I'll do is I'll then be able to switch. I won't be able to see the chats because I don't have my additional screen. I should have set up my additional screen. What I'll do is I'll flick backwards and forwards, I guess, between it. Sorry, guys, this is taking way too long as a starter. I'll just crack on. Today I won't be able to do the chats. I don't think there's any point in me having my camera on, since you're going to be staring at my screen anyway. So let's do that one. This is where it would have been nice actually to have had my camera set up. I'll do that next time, maybe for the next one in about an hour or so. Okay, hide that. You guys should only be seeing my screen at this point. I will just need to, see, the problem is, you see, I need to check that this is still working. It's been a while since I've done this. Go back to my live feed, see if you guys are now seeing just my screen view channel. Should be live. Yeah, look at that alarmer. It's amazing. We are working. Yeah, cool. Still working. Amazing. Okay, right. Let's go straight in, guys, to chemical tests. Okay, make this full screen. Let's zoom in. Okay, so I'm going to be focusing today, guys, primarily on 3 learning objectives for each of the 3 things that each of the series of tests we're doing. So this is AS chemical tests. So chemical tests can be divided into several sections. So we can do chemical tests. We have got our organic, which is what I'm going to be focusing on in this hour. We can then go to the inorganic. Now, inorganic is then subsequently split into 2. So we can then split this then, of course, into our cations, our positive ions. Cats are very positive creatures. And our anions, like it. You can then kind of have another subset of chemical tests, but not so much chemical, so much as machine analysis. This isn't technically, it's kind of a sideline of this. It's not exactly a spin-off of chemical tests because it is a separate set of machine testing. I'll do another video on that one, but it kind of gets incorporated. The 2 tend to be blended. So what I'm going to be doing is I'm going to be focusing today on organic tests on this particular video, and we're going to box them off in 40 minutes. And then what I'll do is I'll then start a next one, and I'll set up my other screen so I can check my YouTube chat window. I might every 10 minutes or so just check that it's actually working, and maybe people will be saying hi. Okay, so here are our learning objectives for my organic tests. I need you guys to know all of the organic families and the tests for each one of those. The great thing is not all of our families have a chemical test, so it makes things a little bit easier. I need you to know the observations, and I need you to be able to write equations for the reactions. Once I've gone through all the various chemical tests, I'll then have a look at some example questions that I've pulled from paper 3s. From the last couple of years. I've even dated them as well, so you can check mark schemes after I've been through them in the video. Okay, so let's just start off. First of all, this is a lovely game to play. So there are 10 AS organic families. So your AS families, I shouldn't call them families, by the way. As a good chemistry teacher, I should be calling them homologous series. That is the correct name for it. Molecules with the same functional group, same general formula, similar chemical properties, and their physical properties increase in a trend with chain length. So a homologous series. And there are 10 of them. If you'd like to do this as a quick exercise for yourself, and you can see how many you can name, you can pause the video now, and then you can have a go at naming all 10 families yourself. It's quite a nice game to play, and I do enjoy playing it. Okay. I hope you guys had fun trying out your 10 and how many you got. Let's see how many you got. So I think the first organic family here to talk about is our alkane family. That's where everything began. That we'd start teaching this in year 10 in our school, and I'm hopefully going to change that to year 9 soon. But alkanes are where we always begin. Then we segue quickly into alkenes. So we've got alkane, alkene. Then we switch. This is still GCSE, by the way. And then we switch into alcohols. I don't know why I decided to put the S on the end of it. Then we go to our aldehydes. This is the first one of our actual AS families, by the way. You don't see aldehydes at GCSE. The first time you see aldehydes properly is in AS level. So we can actually color code this, by the way. The first 3, of course, are GCSE. And of course, they're still there at A level. And then our first AS one is an aldehyde. Then we pick up our ketones. Now, I hope you realize that I'm doing this in a particular order. When I kind of recall these, I pull them out from GCSE, but what I'm doing is I'm going alkane, alkene, then I can transform them into an alcohol, then then alcohols can turn into aldehydes, and alcohols can turn into ketones. So I'm kind of like bouncing from these in kind of a synthesis kind of route. Next one, carboxylic acids. This is GCSE, so we saw carboxylic acids. Carboxylic acids at GCSE, so technically GCSE, but nice to see that it's still there in A level. Okay, next one, we tend to see our cyclos. It's nice to see a cyclo. Now, cyclos, you do visit them briefly in GCSE. They kind of have to be able to deal with them, but not so much naming them or really handling them to any great extent. And you notice that I put cyclo because you can actually have this kind of gains further detail here, because I like to say cycloalk and then kind of go ... because you can have cycloalkanes, you can have cycloalkenes, you can have cycloalcohols. This is like, you can have kind of cyclo anything. Yeah, so it's not really worth me continuing this because it just kind of continues all the way through. I'll put cycloalcohol on there just because it's quite nice because they come up fairly regularly on the tests. But in reality, it's the cyclo term. I like to put that really into an AS category on its own, really, because at GCSE, rather than you just kind of recognize them and manage them. Okay, next one, we have our nitrile family. Again, A level only. So nitriles. This one is a true A-level family. Do you know what I'm going to do? I'm going to switch that one from blue because it's not so much GCSE, really. It's more of an A-level group, really. Nitriles. And then we go for amines. Again, a true amines, a true A-level family. And technically a kind of halfway house, last one, which I always end up forgetting every now and again, haloalkanes. And again, I kind of write a haloalk because you can have a haloalkene. You can have a cyclohalo. That's or a halo cyclo in the case of naming them. So halos are just talking about a group 7, a halogen addition to our organic families. So this, again, kind of halfway house. At GCSE, they do deal with them, but not to the extent that we do at A level. So again, a bit of a halfway house. They see them at GCSE, but they're not naming them or really dealing with to any extent with them. So a bit of a halfway. I guess I could probably say that the cyclos are a bit of a halfway house as well. Okay, could have gone for green, the and yellow. Okay, so we've got our 10 organic families. I wonder how many of those you got. Let me know in the chat. It's always fun to do. Okay, now what I'm going to be doing is I'm going to step through each of these families, and I'm going to be giving you the tests. By the way, test or tests. There are multiple tests for lots of these families, and that is actually something we need to really make sure that you guys are aware of, because certain families have got different tests, and those different tests actually can subdivide within the family itself. We'll see that as we go through. Okay, so let's start off with our family of alkanes. So Okay, we're going to start off with alkanes. Now, as I said you need to know your test and you need to know any observation. Now, the alkane family actually has no specific test to it. So you can kind of say no specific test. And what I would also point out is no specific test. What I would say, though, is, I know this is an odd thing, test for the other guy. Test for other guy. Now, what this means is they tend to put the questions in kind of a pair or multiple situations where they'll say, Pim Pim has an alkane and an alkene. What test could Pim Pim do to differentiate between the two? And what you do is you test for the other guy, because essentially the alkane is a negative test. However, there are certain circumstances where alkanes give an observation with certain chemicals. So this is not really so much a specific test, but it's a test that commonly gets seen, and that is iodine. So you could argue that this could be a test. So this would be iodine aqueous. Now that means iodine dissolved in water. Now, by the way, iodine is not particularly soluble in water, so you actually dissolve it into potassium iodide so that you get ion-dipole interactions, which increases its solubility. But iodine water, I'll actually write that down next to it as well. It's nice to have thorality in the notes. So this is iodine water, and iodine water is a red-brown color. So iodine water is red-brown, and you need to know that. It comes up well. When it comes up, that's often how they'll describe this. So this is a red-brown solution. Now, in the presence of an alkane, what you'll see is you'll often see pictures where they'll have your test tube, and what they'll do is they will add iodine water to an alkane. And when they do this, the first thing to realize is that aqueous solutions tend to be heavy. So due to the density of water, this is our first nota bene of the lesson, by the way. Nota bene. Nota bene. That's it. It's Italian. It's actually Latin, by the way, for important notice. But the nota bene here is that water has a density of 1 gram per dm cube. That's actually super useful because it comes up a lot on paper 3. Water density is 1 gram per centimeter cubed. Notice I'm giving you the A-level unit, by the way, rather than the GCSE with the slash. GCSE is 1 gram per dm cubed, whereas I'm switching to the A-level and I'm using the 10 to the minus because it's the 1 over the reciprocal. So it's nice to know that. Now, most alkanes will have a density far less than that, around about 0.7, 0.8, something like that. What that means is that on the bottom layer of this test tube, you will always have the iodine solution. So this is iodine aqueous. So you start off with a red-brown layer at the bottom. Now, it's nice then to mention, alkanes are not miscible. It's nice to use that term, miscible. So they are immiscible is the key term. So immiscible means that they don't mix. And the reason for this is because this is hydrogen bonded. Yet you've got hydrogen bonding in the water layer. Hydrogen bonding in the water layer, but only LDFs, only London dispersion forces. I call them LDFs and HBs. London dispersion forces in the top one. It's nice just to shortcut that. My A-level students will know how I teach this. LDFs and HBs. So what that means is they're not miscible. They're not going to mix. The alkane won't be able to then dissolve into the water layer. So you'll form a distinct boundary. Yep. So what I'll do is I'll label this over on this side as my alkane. Now we could pick a specific alkane. The most common one they tend to talk about, by the way, is cyclohexane. Don't ask me why they pick it, but they like to. You've got to go above 5 carbons because otherwise your alkane is going to be close to boiling point. Butane has a boiling point of 0. Pentane's around about, 35 or something. So it's the first real liquid at room temperature, but extremely volatile. So cyclohexane's a really good choice. So this is kind of a note for exams, possibly another nota bene, really. So a common one we tend to see is cyclohexane. It's nice to then draw cyclohexane. I'll give you skeletal. So cyclohexane is a common one used in this, and it will be on top because it's lower density. It's something, I don't like guessing on densities, but I always have 0.79 grams per dm cubed, grams per centimeter cubed in my head. It's somewhere around about that. I might be slightly off, don't quote me on that number, but it's somewhere similar to that. So it's going to be on top. Remember, the lower density is going to be floating on top of the mixture. Now, here's the cool thing. Iodine molecules are held together by LDFs only as well. So the bullet point here is that I2 is also held together by London dispersion forces. Nice to kind of draw the picture here. So iodine molecules show temporary dipoles, which then induce dipoles in neighboring, and you get iodine molecules. And here is your LDF highlighted above there, by the way, in green. It's nice to see the link here, up here, yeah? So the LDF, what that means is that the iodine is going to be more soluble in the alkane than it is going to be in the water. It would much prefer to be there. What that means is the chemical test is that the iodine is going to drift. So when you shake this, the iodine actually transfers layers. And we get a new observation. It's actually a really lovely, it's a lovely demonstration or practical. Any teacher, by the way, who watches this is, and who has never done this test before, it's really nice little practical to do just because it's very unusual. And the students always find it really surprising. The bottom layer becomes completely colorless and the top layer turns purple. And I mean, like, by the way, it's quite an intense purple as well. So iodine, and by the way, if anybody's interested, it's the same purple that the gaseous iodine is. It's because the iodine molecules are then freely suspended in the fluid, which means they're acting as single molecules. So the light that's being absorbed is the same frequency that you see as a gas because they're, say, individual molecules too. So the bottom layer, the aqueous layer, becomes colorless, and the top layer becomes purple. As I said, it's not a true test because you could probably argue that this might, by the way, if you do this with an alkene, by the way, you'll get actually the same purple color will transfer up, but then the purple color will fade as it reacts with the alkene turning into the diiodo cyclo, whatever it would be, and whatever the ene becomes turns into the ane. But this turns purple with the alkane. This has also been linked every now and again on papers. This has then been linked to free radical substitution, because if you were to leave this in the sunlight, if you left this in bright sunlight, I'm going really, by the way, I am going all the way to the end of these tests here, folks. So bright sunlight, I'll put sun. The UV, of course, will cause free radical substitution to take place. The UV light will break the iodine-iodine bond, creating iodine-free radicals. Those free radicals will react with the alkane, turning into the iodos, multiple, substitute out the H's, forming HI and an iodo alkane, and the color will then fade over time. So, as I said, it takes time. Even with a UV bulb, that'll take, depending on the quantity of iodine, by the way. So if you leave it in bright sunlight, eventually it will go completely colorless. So colorless after leaving in bright sunlight, because all the iodine will sub on to the alkane. So it's a really lovely thing to talk through. Alkanes, some teachers forget that alkanes can do nice things. They're not as boring as perhaps some people perhaps first think. Okay, let's move on to our next family, folks. Let's go to alkenes. I think this is a good moment, by the way, just for me to really quickly just jump onto my YouTube channel and just to see if anybody anybody's actually said hello. I think that's a really reasonable thing to do. Let's see if anyone's there watching. They probably aren't. It's early in the morning. I wouldn't expect you guys to really be there. Oh, let's get rid of the sound. Hey, I've got BM high. Can you do a lesson on vanadium and standard electrode potentials? Yes, I can do. Please do a lesson on electrochemical cells, Serenity. Evans, hello. Evans is a student of mine in year 10. Evans is awesome, by the way. Yes. I totally get why you want the electrochemical series. It's really tough. And by the way, one of the hardest year 13. I will try and get that done as soon as I can, maybe over this holiday. I'm off for a week. Maybe I'll take the time to do an electrochemical cells one. No, I'll do my best. Cool. Let's get rid of that now. Let's go back to it. Hi, Evans. Thank you for turning up. It's great to see you. These are all the chemical tests, Evans, from A-level. He's in year 10 doing GCSE, but it's really nice for him to see some of these. He'll pick up some of these, by the way, for GCSE. Okay, let's move on to the next one, folks. Let's go to alkenes, family number 2. So fam 2 is alkenes. Now, alkenes have 2 tests, 2 chemical tests for alkenes. So test number 1 of alkenes, I think everyone in this room knows. By the way, at this stage, if you want to have a go at any of these tests before I say them, pause the video, have a suggestion. What you need to do is give me the reagent, the observation, and then the reaction between them. It'd be also nice to draw a mechanism for it if you can as well. Okay, so now that you've had a stab at it yourself, so the test is bromine water. Now you'll notice that I've changed the color of my pen for this, folks. This is bromine aqueous. I say bromine water because that's the correct answer, but I always like to include the state symbol. If you write bromine with an AQ after it, by the way, you'll get the marks. And the bromine water, the observation. Can I please encourage everybody to make sure that when you're giving an observation, you should always give the before and after color. You should never just give the final color. A lot of questions, they will make sure that you are not allowed to do just the final color. They'll say, state the color before and after, but you should always, it's a good routine just to give both. So iodine water is going to change in the presence of an alkene. It's going to change from orange and it's going to go colorless. I think everybody here would happily recognize this one from GCSE. So we're going from orange to colorless. That's the change. It's nice then to look at this in terms of a chemical reaction. Now, in terms of equations, I said to be able to write the equation for this. You can do this as a structural equation. So the equation for this, I'll just write equations as EQ. I'm going to start off with CH2, CH2. So what I'll do is I'll do the structural and the displayed simultaneously. That way I can show you the mechanism. It's just a nice opportunity for me to link in mechanisms to all the chemical tests because, of course, they'll do it in the exams. And I'm going to then add to this bromine water and Br2. And don't forget, you've got to have your aqueous. So I'm going to highlight that in orange because it's nice to remind us, just constant reminder, right? And we're going to be reacting this with Br2. Now, if I'm going to do the mechanism side by side, I'm going to have to put the Br in a specific location. So I'm going to put the Br down here to do the mechanism. Okay, so what's the structural endpoint? I'm going to get CH2Br, CH2Br. Yeah, students struggle with structural equations, by the way. They really find it difficult. So this organic product, by the way, is completely colorless. It's also a liquid, by the way, just so you know. You'll end up with two layers. Again, the bromine, the water that the bromine is in will actually remain at the bottom, and the bromine will then move up. Okay, so what's happening in mechanistically, or what a horrible word, you have a temporary dipole during collision. That's a common question in the exam, by the way. Explain why bromine can react with alkenes when it's not polar. During collision, the bromine becomes polarized. So that's a little note that you can add to your notes if you want to. Note where I'm starting each of my, kind of do my curly arrows in green. Start in the middle. Notice where I'm starting. The bromine, the double bond reaches out and it's going to go for that Br. And this bond then has to go. So bromine can only make one bond at any time. So if the double bond is breaking and forming a new one to the Br, then you've got to have the other bromine bond break. So arrow in terms of our mechanism. Double bond's gone. And we end up with a really cool intermediate, a carbocation intermediate. Now, this is not a lesson on mechanisms here, folks. You know, if you're wondering about all the other unsymmetrical alkene addition reactions, that you need to watch my videos then on electrophilic addition of alkenes. So this is the mechanism that's happening, and it's nice to actually draw the final product to show you how it relates to my structural equation. You can see the CH2s. I'm drawing the CH2s first because these are the originals, and then the bromines are attached onto either side of the double bond. It's nice to remind you, it goes on either side of the double bond. So this is electrophilic addition. This is EA, electrophilic addition as a mechanism. Electrophilic addition. Cool. Okay, so that's the first test for the alkene. Bromine water, orange to colors. There is a second test. And by the way, it's nice, Evans, both of these tests are technically able to be asked at GCSE, just so you know, they can actually be done. So this was test number 1. I should do alkenes test 1 really for this. I need to make that really clear. There are multiple tests for these. Test number 1 for alkenes, there is another, test number 2. So the second test is potassium permanganate. Notice I'll do it in black and then go over the top. KMNO4 aqueous potassium permanganate solution. Yeah, and it is a beautiful dark purple. Dark purple. It's a lovely dark purple color. And potassium permanganate is a really nice test. The observation with the alkene. The observation is it goes from purple to colorless. Observation. It's French for observation. Sorry, my kids in my class will know that. Sorry, ignore me. Observation is purple to colorless. I'm doing my colorless as these little clouds. So we've got purple to colorless. I'll explain why purple two colorless. Always give your two colors. So what's happening in this reaction? So by the way, the purple color is not the potassium. It's actually the MnO4 minus ion. This is called, by the way, this is called the permanganate ion. The permanganate ion is dark purple. And what's happening to it is it's actually forming Mn2 plus. Now, Mn2 plus, by the way, in year 13 is pale pink, but you're allowed to actually call it colorless. Even at A2, you're allowed to call it colorless, but you have to know that in case they say it. So, for you guys, just know purple to colorless. So it's actually being reduced. So it's nice then. So for Evans, who's in the lesson, Evans, the manganese atom ion in this is actually in a +7 oxidation state. So I'm just going to give Evan a quick tour because he's never done oxidation states on charged ions before. MnO4 minus, what's the charge on the manganese? Well, we know that oxygen is always O2 minus, except in hydrogen peroxide, and there are 4 of them. So there's a total of 8 minus on this. Now, the overall charge of the molecule, or the ion, sorry, of the anion is -1. So I've got to have manganese bringing a positive charge that will take me from -8 up to -1. So this has got to be +7. It's nice to see that. So this is manganese +7 oxidation state. So it's being reduced. It's actually gaining 5 electrons. So this is a reduction. The question is, what is it turning the alkene into? Now, this does come up on the exams fairly regularly, so do learn this one. The alkene is actually, if the manganese is being reduced, the alkene is being oxidized. And what's happening here is you don't need to know any mechanism to do with this. All you need to know, MnO4 minus, and what I am forming is a diol. I know it's an odd switch. It's because it's in water, if you're interested. The manganese, the permanganate ion is giving up oxygen. And then those oxygens are just going to pick up H's from the water. I will also say, by the way, this, I'm sorry, I missed a bit. Detail, Mr. Duncan. This has to be acidified. So this I'm going to put in red because I've missed it. It must be acidified. So just so you know, acidified. It must be in acid. In acid. And the acid, by the way, if they ask you for the reagents, the acid we use is dilute sulfuric. Dilute, you cannot say concentrated, by the way, because that will do all kinds of wonky stuff. But it's dilute sulfuric is the acid we actually acidify it with. And you form a diol. And the permanganate ion turns from MnO. By the way, I can do all the half equations for you, but that is not the purpose of this lesson. I'm just doing the chemical tests for organics. So 2 tests for alkenes. Those are the major 2. They're the ones that we commonly see. And so we'll move on to the next family. 2 down. Let's move on to the next one, alcohols. Okay, family number 3, alcohols. Oh, come on, Mr. Duncan. Alcohols. Okay, so alcohols, there are 3 chemical tests for alcohols. I'm so sorry, everybody. There are 3 tests, and we've got to be really careful with each one of them. So, okay, the first test. Now, by the way, I'm actually changing the order of these. Test number 1. I'm going to do test 1. I should actually be putting test in front, right? Test number 1. Now, what I'm actually going to give you here, folks, is a slightly different order that you'd probably expect. I'm going to be giving you the test in order of the tests you can use for any alcohol. Yep. So the first test, this can be used. This test is for any alcohol. Yep. So primary, secondary, tertiary, it will work for every single one of these alcohols. That test is sodium metal. So sodium metal. And that's the test. You add, just to say add sodium metal to your alcohol, and the observation is fizzing. I love fizzing. By the way, if you can spell effervescence, knock yourself out. I don't write it. Effervescence. Is it an ES or a C? I don't know. Something like that. Effervescence, the fancy word fizzing. I just don't write effervescence, by the way, because I can never spell it, so I just spell fizzing. So the observation is fizzing. So the question then is, what is happening in terms of the reaction? So what is I'm going to stick with the most basic alcohol for this, folks. I'm going to give you methanol. It just seems like the right thing to do. So here's methanol. We're going to react this with sodium metal. This is the equation. Should be good. Come on, let's look. Equation. And I'm going to add sodium metal to this. So what am I going to create? I am going to create a rather lovely substance called sodium ethoxide. That's what I'm going to form, which is this, and hydrogen gas. For A-level students only, balance with a half. Gotta love it. I love balancing with halves. Evans, you shouldn't really balance in halves, although technically, by the way, so this is called sodium ethoxide. By the way, they have asked for the name of this once or twice. Really weird. It must be in the textbook somewhere. Sodium ethoxide. And so this is what's happening. So essentially, by the way, the alcohol is acting as an acid and the metal is acting as a base. You can also look at this in terms of redox. The sodium is being oxidized and the hydrogen is being reduced. But a very simple chemical test, and it works with all alcohols. You'll get fizzing with any of them. Test number 2, another test that can be used for all alcohols. So test number 2, let's just underline this. Test number 2. Test 2 is PCl5. Test number 2 is pickle. So PCl5. So this is again test number 2 for alcohols. By the way, I'm hoping you guys are just gonna I don't need to be writing alcohol all the time. So test number 2, the reagent. By the way, reagent is the name on the bottle, like sodium hydroxide, sodium metal, PCl5. The reactive species, by the way, up here, the reactive species would be MnO4 minus rather than the reagent would be KMnO4. Just to let you know, it's like there's a difference between reagent and reactive species. So this is PCl5, a white solid phosphorus pentachloride, trigonal bipyramidal in shape, 90, 180 degrees. We can draw the shape if we wanted, but this is not a shape lesson. So what's the observation with any alcohol? Any all. Observation is misty white fumes. Misty white fumes. Let's look at the equation, and they will ask you for the identity, by the way. I will tell you, by the way, that PCl5 has a problem. PCl5 will also work for carboxylic acid. That's a nota bene. By the way, it's going to appear when I get down to carboxylic acid. So nota bene here, folks. Also for carboxylic acids. Yeah, for goose, for oics. So watch out, be careful. If they give you an ol and an oic, then you can't use PCl5 because both would give you fizzing, well, both would give you misty white fumes, which means you wouldn't be able to distinguish between them. So you switch to, oh, by the way, can't use sodium metal either. Sodium metal will also react with carboxylic acids to give fizzing. So you see that there's problems with all of these because it's acting as an acid, right? So that's a nota bene as well. Yeah, or also works for oics. But you don't use it as a test for oics. Also works for oics. Nice for me to write oics and then them down below. Oic acids. I've written down their functional group of it. Kind of nice to see there's the differences. These are the same boxes, by the way. Same thing, because that's the functional group. You get it. Okay, so PCl5. It'd be nice to be on when we get to the questions. You'll understand this a little bit more. So observation, what's happening in terms of the equation. So what's actually happening here is I'm going to start again with methanol. I'm going to switch to a structural formula rather than displayed here. PCl5 is a powerful chlorinating agent. So I get PCl5. And what it's going to do is it's going to push chlorine onto the alcohol. So it's going to actually, as I said, it's called a chlorinating agent, and I'm going to get CH3Cl, chloromethane. And what I then get, and by the way, I always recommend to learn this, POCl, POCl3, POCl, cool. And HCl, there's my misty fumes. Yeah, there is my, and by the way, it should balance, I think. Yeah, looks like balances. And this, the identity of the fumes. So these are the misty white fumes. By the way, do you need white? Yeah, you should do. Misty white fumes. I'm trying to think of any fumes that you get. Yeah, you could get fumes of brown gas, of NO2 or bromine. So white, so yeah, we conclude it. Okay, test number 3, PCl5. Nice and straightforward, misty white fumes. Poof. Number 3. This is the one I think where you guys will all go, oh yeah, I know this one. This is the one that I learned. Test number 3 for alcohols, last one, folks, is acidified potassium dichromate. Acidified, notice I'm switching the acidified this time, folks, to be in front. By the way, you shouldn't really say that. I'll explain in a sec. Acidified potassium dichromate. By the way, Evans, this is actually on for GCSE. Acidified potassium dichromate. Be careful, Mr. Duncan. Come on, potassium dichromate. Which is orange, by the way. Just to tell you, by the way, I actually hate what I've just done, because the reagents for this, you've got to be really careful, because acidified isn't a reagent. The reagent is K2Cr2O7, or in words, acidified or potassium dichromate, and the same reagent we saw with the permanganate, which is we're going to use dilute dill H2SO4 to acidify. Be careful. If they ask for the reagents, you've got to include the sulfuric acid. You cannot say acidified. Just be careful. By the way, these two are interchangeable. They often allow formula and names, especially at AS. Cool. So what's actually happening? So observation. What are we going to say? So now this is where things become a little bit more interesting with alcohols. So observation, we now have to subdivide into our primary, secondary, and tertiaries. So we've got different observations. So with a primary alcohol, so I'm going to put this as like a #1. So primary alcohol is going to go from orange to green. Yeah. So it's going to go from orange and it's going to turn green. Now, in year 12, you don't have to know the species responsible for these, but in year 13, you do. So it's nice then to give you this. Cr2072- is the orange species, and Cr3+ is the green species. So it's actually being reduced because the chromium, if you want to pause the video, have a go at doing the oxidation state, knock yourselves out, have fun. The oxidation state of chromium here is a +6 oxidation state, and it's being reduced from +6 down to +3, which is a green color. So, and here's the next thing. So what's happening to the primary alcohol in this scenario? Now, by the way, they're going to give you a particular condition for this, because if you take a primary alcohol like ethanol, let's always go to our favorite Friday night molecule. This is a primary alcohol. It's a primary alcohol because the carbon with this carbon here, this carbon here has one other carbon attached. So it's going to be primary. 0 or 1 carbon, primary. 2 carbons, secondary. 3 carbons, tertiary. So in this case, if we now add this to acidified potassium dichromate, what's going to happen is it's going to be oxidized. I'll actually show you one of the equations that you'll see. It's going to be oxidized. And if we do it under distillation conditions, I'm switching into alcohols. If I do this under distillation conditions, it'll be converted into the aldehyde, into ethanol. And then if I were to be doing this under reflux with excess potassium dichromate, so this was under heat and reflux, then it'll turn it into the oic. So you have to build the equation depending on what they're asking you to do. It'll be interesting to see if I see one of those questions turn up on one of the questions that I've picked out. But primary alcohols give you a flag with acidified potassium dichromate. Let's have a look at secondaries. Zoom back in. So #2, secondary alcohols also give a flag. Secondary alcohols will also give a positive test. Secondary alcohol will also go from orange to green. So the question is why? So same thing is happening here. I'm not going to write down observation all the time, guys. I think you've kind of figured out what this is doing. Orange to green. I feel like I should be writing it for the thoroughy of my notes. Orange to green. Always give both before and after colors. Secondaries will also give a positive test. The reason being is a secondary alcohol, such as propan-2-ol, a secondary alcohol, will be oxidized to a ketone, but then stops. So this is our propan-2-ol secondary alcohol. Yeah, look, carbon attached in the center is joined to 2 other carbons, carbon number 1, carbon number 2, secondary alcohol. This will indeed be oxidized plus oxidizing agent. By the way, notice I'm not balancing any of these. They do need balancing. I'm not giving you an alcohols lesson. I'm giving you a chemical tests lesson. But essentially what's going to happen is it's going to be oxidized up to our propanone. And therefore, if that's being oxidized, then the potassium dichromate is therefore being reduced. So gives a flag. Now, tertiary alcohols doesn't work with this test. So tertiary alcohols will give a negative test on this particular choice. So it will remain orange. Observation, no change. By the way, if there's ever no change in a reaction, just write no change. Yeah. Don't write no observation. It meant you did it blindfold. Don't write it. You can put it remains the same color, it remains orange. That's totally fine. But no change is always the choice that I would always give you guys. Cool. So we've got 3 tests for alcohols, all with slightly different levels, which is amazing. Let's tick them off as we go. So I've done alkenes, I've done alcohols. We're on to aldehydes. Okay, so aldehydes. I don't want to get my writing get too big. So moving on to the next family, folks. Test for aldehydes. Now, I will tell you, by the way, folks, that the test for aldehydes at AS level is fairly straightforward. There are 2. I should actually do, by the way, I can put 2 families together here, because what I should say is this is the test for aldehydes, but they will always compare you to ketones. There are no tests for ketones at AS level. There are at year 13, but not in AS. What that means is these 2 are going to be paired. They're going to say Sibylla's got an aldehyde and a ketone, and the bottles weren't labeled. What chemical tests could she do to distinguish between them? And you'll give either one of the 2 tests for aldehydes because the ketone would give a negative. What that means is, guys, I'm going to skip the ketone family because that's only in year 13 where you see it. So test for aldehyde groups. CHO. So RCHO is the structural formula of an aldehyde. So test number 1, there are 2 tests for aldehydes. So test number 1, don't know why I keep flagging the numbers in blue, go figure. Test number 1 is Tollens reagent. Tollens, what a great name. Love Tollens reagent. Now you have to know what Tollens reagent contains. So by the way, this is the reagent. If they ask you for the reagent, it's Tollens reagent. And Tollens reagent contains silver 1+. In year 13, you know it contains, it's actually ammoniacal silver. It has another name for this, which is ammoniacal silver nitrate. Ammoniacal silver nitrate. It has been asked on papers before, silver nitrate. Horrible thing to call it, just Tollens. Ammoniacal silver nitrate, and it contains Ag1+. So the observation then, so that's the reagent. If you can change your notes and write reagent if you want to, but I've got reagent there, so it's there. Observation is you're going to see it turn from colorless, so observation, colorless, to a silver mirror precipitate. Colorless to a silver. By the way, you've got to be really careful with this one. You cannot say mirror precipitate. You can say silver precipitate. They will allow that, but they won't allow just mirror. There are other metals that we now use to make mirrors, chromium being the main one. So if you're going to say it, the correct response, the best response is a silver mirror precipitate. Precipitate. If you actually just said silver mirror, you get it. If you just say silver precipitate, you get it. But it forms a silver mirror. It's actually a really pretty test. If you do it well, it's gorgeous. And this is the test for aldehydes. So now we need to understand it in terms of the equation. So it's happening in 2 parts. So what I'll do is we have the Tollens reagent, the equation. The Tollens reagent contains silver 1+. And silver 1+ is becoming silver metal. Now, Evans, I'm kind of doing this for you because it's nice to link what we've been doing at GCSE Redox into these tests that are in AS chemistry. So we can now, Evans, pause the video, balance the half equation for me. It'd be really nice for you to see this. So silver metals are solid, Ag+ is aqueous. And we can balance the half equation by adding 1 electron. So what's happening? I'm going to put the 1 electron in, I don't know, red, whatever, 1E-. So it's gaining electrons. Oxidation is lost, reduction is gained. This is reduction. So the silver is being reduced down to silver metal. This is red. This is reduction. So that means it must be acting as an oxidizing agent. It's oxidizing the aldehyde. The question is, what will it oxidize it to? So in this case, the aldehyde, let's do a real one. It's nice to do a real one. The aldehyde is being oxidized up to a carboxylic acid. Now, just to tell you, Tollens reagent does not work with an alcohol. Some students make the error that Tollens reagent, because it can oxidize aldehydes to carboxylic acids, they often make the link that it's going to oxidize alcohols to aldehydes. Well, it's primary anyway. The answer is it doesn't. This is a nota bene. Nota bene, Tollens is a mild oxidizing agent. Oxidizing agent. And therefore, so won't. So will not, won't oxidize alcohols. So it does not give a false positive with alcohols. This is for aldehydes and ketones, because with aldehydes, they can be further oxidized, but the ketone, of course, cannot. Yep, ketones will so we can see from this, as I said, I'm not trying to teach you an alcohol lesson here, folks, but it's just nice to flag, a primary alcohol does oxidation twice, and whereas a secondary alcohol does oxidation once, and tertiaries resist oxidation. So that's a nota bene up here, by the way. Tertols resist oxidation. They resist oxidation, by the way, because there's no hydrogen. There's no hydrogen on the carbon. On a tertiary. There is no hydrogen on the carbon with the alcohol group, so you can't oxidize it up to anything else. I know that seems like an odd thing to say, but it's that. Yeah, that's the way it is. Cool. I'm tempted to actually balance the half equation, but it would be genuine AS. I mean, okay, I'm teaching this lesson, so let's balance the half equation. It's nice to see how Evans, you're going to get a sneak peek at what a redox half equation looks like at A level rather than GCSE. So we're going to go from, we've gone from methanal, so we've got methanal CHO, and we are oxidizing it plus O in a square bracket means oxidizing agent, and I'm going to be forming this. Now, what I'm going to do is I'm just going to get rid of the oxidizing agent and balance the half equation so we can see it purely from an electron standpoint. Now, when you balance equations in AS chemistry for redox, we use MOE, metal, water, acid, electrons. So the metal is anybody not oxygen and hydrogen, so in this case, carbon. So one carbon, every metal done, or anyone who's not hydrogen oxygen is done. Right, next one, water for oxygen. I've got 2 oxygens here, but only 1. I need to add the H2O to that side. Cool. Next, I need to add acid for my hydrogens. Now, I have got 1, 2, 3, 4 hydrogens on this side, but only 2 on this side. So I'm going to put 2 H pluses over here. So there's my acid. Okay, next is my electrons. I've got the balance for charge. Now, we know that this is an oxidation. Oxidation is the loss of electrons, so this is looking good so far. I'll finish it off with this side having an oxidation state of 0, no charge, no charge. And this one having an oxidation state of 0 and +2. So +2 overall, add 2 more electrons and we're done. That's how you balance half equations. Evans at A level. Just a little bit of, you just do electrons and atoms with like singulars, but it's nice. It's nice. It's not actually as hard as it looks. Cool. So we've done aldehydes. Are there any other tests for aldehydes? Don't think so. Not at AS level. Oh no, of course there is. Ugh, idiot. Test number 2. Oh, there'll be people going, there's another test, Mr. Duncan. I know there will be. Test number 2, failings. I hate this test because it's not even chemistry. It's biology. Benedict's slightly different condition though. This is called failings reagent. So this is the same as Benedict's, by the way, for the biologists in the room, and it contains copper 2+, and copper 2+ is blue. So failings is another mild oxidizing agent. So we'll put mild oxidizing agent, exactly the same as the Tollens oxidizing agent. Mild oxidizing agent, and it's going to take the aldehyde to a carboxylic acid again. Nice and easy. Going to start with methanal, going to oxidize it using failings, and I'm going to result at methanoic acid. The question is, what's the observation? I've done the equation before the observation. My bad. Sorry, folks. Observation is blue solution. Observation. A blue solution. Be careful when you're stating these things. And it's just like that, by the way. This is a blue solution, blue sol, and it forms a orange-red precipitate is what it's forming. That was not what I wanted. I wanted a highlighter. An orange-red precipitate, or brick red sometimes, but Edexcel seem to prefer orange-red. So this is orange-red precipitate, PPT, precipitate. So the question is, what's happening in terms of the copper? So what's happening here, folks, is that copper 2+, which is blue, is actually forming copper 1 oxide, a really bizarre compound. Should actually be, in year 13, this makes an appearance because it should actually be white, but it's not. It's a standout oddity, copper 1 oxide. And it's a Roman numeral number 1 oxide. It's a very strange oxide. Does come up every now and again, but it's a rare question. There are no other tests for aldehydes or ketones. So at this point, I have to kind of make the note, don't I? Ketones. No tests at AS. Ketones, no test. No test at AS, but there are tests at A2. What it is test for the other guy. We know this. We'll go with that. Test for other guy. Test for other guy. It'll give you other guy. It'll give you no observation, no change, no change. Test for the other guy. Yeah, they'll usually compare these to aldehydes, maybe alcohols, but usually aldehydes. But partly because they're functional isomers of each other, by the way. They do like that. Okay, so ketones, nice and easy. Okay, so I can tick off aldehydes and ketones. We're doing really well. Halfway through already. This is great. Okay, test for carboxylic acid. Well, we already had a quick mention of this. Wow, my writing's getting bigger as we go down. I'll shrink it all so it's all the same size. Okay, carboxylic acids, folks. We're getting there. We're nearly done. Halfway through. Carboxylic acids. Carboxylic acids. Okay, carboxylic acids are bond C, double bond O, bond OH. It's nice to see the functional group written COOH. Cool. How do we test for this family? I should have been doing that each time, shouldn't I? So reagent for the test. Reagent. So test number 1. And by the way, this is the most important test, really, folks. So test number 1. I don't know why I keep doing the numbers in blue. Don't quite get what I'm doing there. It's weird. Test number 1 is sodium hydrogen carbonate. They will allow, or I don't like it, by the way, but they will allow you to say sodium carbonate. I don't like it. This is the real test. I prefer you to use that. Because, by the way, that one always works. The sodium carbonate doesn't work unless the carboxylic acid is in massive excess. So that's another year 13 acid-base trick, by the way, but still, that's the best test. Sodium hydrogen carbonate, observation. By the way, you can do either solid or aqueous, either one. Yeah, observation is fizzing. Observation, fizzing. We're going to generate carbon dioxide. You can say effervescence, but I can't spell it, so it's fine. So what's the equation? Let's have a look at the equation, folks. So the equation, very straightforward. I'm just going to do it as ROOH, and we're going to add sodium, hydrogen, moving the mouse, carbonate. Okay, what's going to happen? Well, this is just an acid-base reaction, right? So the sodium is going to swap places with the H. Yeah, I'm going to form ROO minus, the salt, and the Na is going to join on as a plus. Remember, it's not covalent. Yeah, so what else am I going to make? Well, I'm going to make H2O and I'm going to make CO2. And there's my fizzing. Yeah, I'm suddenly realizing my writing is getting larger. Just going to quickly shrink that back down. I really ought to check my YouTube channel just to see whether or not my sounds all stuff. Yeah, anyway, you kind of get it. So anyway, so it fizzes. Yeah, and by the way, we tend to tack this onto a gas test. We then tend to bubble through lime water. Yeah, test for carbon dioxide. Yeah, bubble through lime water turns cloudy. By the way, don't forget the bubble through. Bubble through. People just say lime water. No, you've got to say bubble through. Be careful. Yeah, and it'll turn observation is turns cloudy. Yeah, it turns. I don't actually like that. You should say white precipitate. It's a better answer, but they allow it, which is stupid, by the way, but whatever. Okay, I'm not doing gas tests on this particular session, so I'll come back to it. There is another test for carboxylic acids, sodium metal. You're kind of getting the premise here. You could also do, from GCSE, you could also add an alcohol plus a few drops of concentrated sulfuric acid, and you'll get a fruity smell. You're going to see that's the formation of an ester, but I always think it's not a great test for carboxylic acids. I just think it's a bit of a lie. And so the other tests, which I think I have already mentioned this, folks, which is, and I'm just going to flag these as test 2, because we've already kind of mentioned this. You can use PCl5 and it'll give misty white fumes, already seen above. Yeah, misty white fumes. Not a very common thing for them to make you do of HCl gas. You can also do test number 3 with sodium metal. That would work, but I'm just being super thorough here, folks. These are not common. Yeah, they're usually using these. You'll see it in the questions in a minute. And this will fizz. You could light the gas on fire and then get a squeaky pop test for the hydrogen if you wanted. You could argue, I've never seen it today, but I'm being thorough, and that the day I don't teach it is the day it happens. You could technically add an alcohol, and conc H2SO4 sulfuric acid. It'll become an ester. And the observation would be fruity smell. I don't like it. It's a rubbish test because it's so difficult to really make work, and you have to neutralize it. It's a whole load of problems, but you'll see it on mark schemes, so it's good for me to be thorough. Okay, carboxylic acids, done. Sodium hydrogen carbonate, best test. Cool, next one. Right, cyclos, no test. But remember, the key thing here is there is no test for a cyclo itself. But we realize that if you've got a cycloalkene, you could test for the ene on the cyclo. If you had a cycloalcohol, you could test for the alcohol group on the cyclo. There's no specific test for a cyclo. I will mention, though, they often do, and this is a nice little note to make. I'll do this under my cyclo heading. So I have no idea how long this has been going on for, by the way. So cyclos. So cyclos, ... These are usually compared with alkenes. There's a reason for this. So if we do, okay, just to show you why, C3H6. Now, for GCSE students, they'd probably immediately go, propene. That's what I'd say for that. Because what we know is because it's CnH2n, there's no +2, we would have a double bond in here. So they're going to immediately look at this and go, propene. But actually, there is another structure. There's a functional isomer of this. It could be cyclopropane. And this is what they usually do. Yeah, this is usually how cyclos make themselves appear in chemical tests. They'll go, Stephen has an unknown bottle with the formula C3H6. He doesn't know if it's cyclopropane or propene. What could he do to test for this? And you just go, add bromine water. Yeah, so if you add bromine water, then the alkene is going to go colorless, and the cyclohexane will just no change. Done. So just to be aware, no real test for the actual cyclo part. It's a test for the other guy. So I'll write that down. Test for other guy. No, and these would always be no change for these guys. Yeah. Just remember, if you've got a cycloalkane, you can test for it with iodine, but that's really the test for the alkane group rather than it being cyclo. That's my point. Test for other guy. You get it. You get it. I like this. I'm having fun. Nah. Okay. Next one. Cyclo's done. How are we doing? We're doing really well. I'm enjoying this. Cool. Done, done, done. Boom. Okay. Cyclo's finished. Okay. On to nitriles. This is a great one. No test for nitriles, folks. Isn't that awesome? We can convert them, by the way. You can actually hydrolyze them. And it's a year 13 trick rather than AS. So I'll write it down anyway. It's nice to always have the section in the notes in it, just to be able to go nitrile. Partly because, some people will be going, I didn't even know I had to know nitriles. R bond C triple bond N, or just RCN. This family is called a nitrile. So for those people who haven't met them, there'll be probably some people who won't have met these before. Some teachers just seem to skip them. They shouldn't, but anyway, because you get this in nucleophilic substitution of cyanide with haloalkanes. But this is ethane with an E nitrile. Ethane with the E nitrile. The E is there to separate the two ends. Otherwise, ethanitrile sounds like you have a stutter. So there is no test for this family. No test. Even when you get to year 13, by the way, even when you get to year 13, we can react to this. We could add sulfuric acid to this, and it'll turn into the carboxylic acid. You can hydrolyze it, and then you take that carboxylic acid and you add the alcohol to. But it's all a bit stupid, so no test, which is great. We can skip it. Test for the other guy. The last time this made an appearance, by the way, they did the test for the amine. I think we're on our last family. Are we on our last family? This is awesome. No, halos. So we've finished our no test for the nitrile. On to the amines. Amines only have one. By the way, amines only have kind of one real test, especially at AS level. I can't even remember the last time I saw it. So amines, which is R bond NH2. R bond NH2, written R, just NH2 like this. My go-to guy, I should have been giving you my go-to guys for all of this. I should have been doing it. See, I'm picking up as my lessons evolving as I'm doing it. It's nice to see that I'm just, anyway. So this is ethanamine is what it is, ethanamine, or aminoethane, or ethylamine, God, old names, but that's the one they now want. Okay, this family, essentially very few tests. You can do things with it in year 13, but in AS level, very little. Very simple, amines are basic. You will add, so the reagent, so test, and there's only one. Test is universal indicator. Universal, and I don't know what I'm trying to call it. Universal indicator. You could technically use damp red litmus. You could just use red litmus. Universal indicator is a better choice. And the observation is it will turn blue. Yeah, it'll turn blue. By the way, this is an interesting one. There's no before and after. Universal indicator paper starts off green, by the way. It turns blue because it's a weak alkali. Yeah, blue turns blue. It is a weak, not strong, a weak alkali. Sodium hydroxide would turn purple with universal indicator. Can't even remember the last time I saw this family make an appearance, by the way. There is one other thing which I'm going to tie on to this family. There is another test, and actually it's just come to my head. It has been asked. I can't remember how recently. It just popped. There is another test for this, and probably a better test too. The organic. So test. What am I doing? Test 2 is concentrated. It's interesting, isn't it? All this stuff. I have to just pull all the stuff out of my head. Test number 2 is concentrated. I'll actually write it properly. Concentrated hydrochloric acid, HCl. And what you'll get, the observation is white smoke. Notice it's not misty white fumes. It's not fumes. This is actual smoke. Observation is white smoke. So just to show you why this is because it's a bit like the test for ammonia. This is a test for the ammonia gas. It's the same actual test, because what's happening is I'm forming the salt. If I do methanamine, nice short methanamine, and I take this amine and I react it with HCl, what I'm going to create is a salt, and it's very exothermic, so it'll leap out the flask, and I will form ammonium chloride. I'll form ammonium chloride salt. Ammonium chloride. And you get white misty smoke. Sorry. Oh, methyl ammonium chloride. My bad. It's organic. Apologies. This is methanamine. Oh, I'm not flawless. I don't pretend to be perfect, by the way, folks. And it has to be conch, by the way. The aqueous won't work, so it just dissolves and you don't get the white smoke. So methyl ammonium chloride and white smoke, because it leaps out the beaker. Very exothermic. And I believe that brings us to the end of our org. Oh no, one more to go, folks. I have no idea. Let's see who said hi on the chat. Who said hi on the chat? I feel like I want to have a look. Let's have a quick look, folks. It'd be nice to say hello to anybody who's there and decide. I have no idea how long my lesson's been going on for, by the way. I haven't got a clue. Really hoping everything's working. You view your channel. Oh, it's going to say I'm live still. I'm really hoping the sound still works. Yeah, it's still there. Yay. Okay. I've got Rajul. Have you done AS chemistry about 2 years ago, but suddenly saw you live and came to let you know you helped me a lot to complete A-level chemistry and finally start my Razel, thank you so much. You are more than welcome. Thanks. You have some of the best A-level chemistry. Or thanks very much. That is such a nice thing to say. Heart, thank you so much. I really, really appreciate that, guys. Thank you. Us teachers get so little praise and so little thanks, so I really appreciate that. I'm glad it's all still working as well. I also have no idea how long it's been going on for. It doesn't even tell me. Amazing. Let's close it down and finish. Okay, last one, folks. Halo alkanes. By the way, not just halo alkanes, halo alks. Yeah, it's our last one, number 10. Have I just lost all my numbers? I really wanted to go through my families in order, like family 2. I can do that. Alcohols were family number 3. Aldehyde, look at all that. Aldehydes were number 4. Ketones were number 5. Carboxylic acids, number 6. Nitriles, number 7. Amines, number 8. Oh, have I lost one? Cyclos. Have I missed cyclos out somewhere? Probably. Nah. Lol. Not that it matters. Anyway, final one, folks. Final one. Final family to test for are halo alkanes. Now, by the way, it is halo anything, just so you know. Halo alks, ... Yeah, you're testing for R. Shouldn't do that, by the way. It should really be R bond C with a Cl or a Br or an I. Yeah, so, technically R bond Cl, but you kind of get the premise. Like, it's this bit that we're testing for, the halo group. Yeah, we also know that you can have an R bond Cl, R bond Br, R bond I. You can have R bond F, by the way, but you can't test for R bond F because F can't come off. The bond's too strong, won't break off. So how do we test for these? We test for them with a very simple test. So the test for this, test number 1, is we're going to test for this with aqueous silver nitrate. So, by the way, it actually should be acidified silver nitrate, really. This is silver nitrate, aqueous solution, silver nitrate. It doesn't know. It's a really interesting one to talk about the whole, does it need to be acidified in this setting? Technically, it doesn't. The reason being is that the chloroalkane is an oil, so it's not really going to interact all that well with it anyway, which means it's not in solution. If you included the nitric acid, they wouldn't care. I'm pretty sure it would just say in the extended markings section, it'll say ignore nitric acid. So you can just do it with silver nitrate. So the reason why, what's happening here is, and it must be aqueous, that's the important bit, because it's actually going to go through nucleophilic substitution with the water. It's kind of a nice test. If I do chloromethane, which is a gas, by the way, not that it makes any difference, let's just call it a liquid. The silver nitrate is water, silver 1+ floating around with water molecules. Well, what's actually happening is nucleophilic substitution. First step in any mechanism, find your delta. No delta, no reaction. Leave from the middle of the lone pairs, attacks the C, bond breaks going to the Cl. And I'm now getting in. This is nucleophilic substitution with a weak nucleophile. So now the oxygen becomes fully positive because it has 3 bonds. Another water comes along, changes its role from a nucleophile to a base, takes a proton, and that rolls back to regenerate the oxygen's lone pair. This one's a nucleophile, this one's a base. And I end up with an alcohol. So that's all I've ended up with, plus acid, by the way. I'm generating H3O+, which H3O+, by the way, is literally the real version of H+, just so you know. But here's the extra kicker. I have chloride ions floating around. And what now happens? And this is actually the more important equation. Ag1 plus can now pick up Cl minus aqueous to form solid silver chloride. And that is a white precipitate, white PBT. Now, at this point, I need to then give you all the other options. I'm going to be recovering this in my anion lesson. So we're going to see this again, folks. It's going to reappear, but it is nice to do it. If it was a Br, the Ag plus would be reacting. I'm writing these equations again. I'm going to form AgBr as a solid, and it is a cream precipitate, cream PPT. Or if it was an iodo, then the iodide would fall off, and I'd pick up silver iodide as a solid, a yellow PPT. There are confirmation tests for these, by the way, in terms of colors. I'm going to do that in my anion test. What I'm going to now do, folks, I have come to the end of all the organic tests. Nailed it. Please, if I have missed any organic test that you have come across in a question, please leave a message on the chat and I'll add it to the video. But actually, we're done. So let's now have a look at some questions that I pulled from papers. Okay, this is going to be much more interesting. I haven't taken the mark scheme, by the way, but I do have the years. Right, let's have a look at the questions. Okay, let's apply what we've just learned. State a chemical test for the OH group in ethanol and a chemical test for the Br group in bromoethane. Include the expected positive observations. I like it. Look at the lines as well. Kind of like this. So the test for this alcohol group. So by the way, it's in ethanol. What that means is it's a primary. I can give any one I want out of the three. Let's go for our good old classic. I'm going to say, by the way, notice it just says state a chemical test. I'd probably be allowed to say acidified potassium dichromate, but I'm actually going to say potassium dichromate. I'm not going to give the formula. It does say state, which means it hasn't say give name or give formula. It'll probably accept either, but I like writing the words if they haven't told me. Potassium dichromate and dilute sulfuric acid. I'm going to change that to the formula. Dilute sulfuric acid. And the observation is going to be orange to green. Always give the before and after. Orange to green. I like it. We could have alternatively done sodium metal and it would effervesce. Or we could have done PCl5 and it would have given me misty white fumes. I would have done either of those. Right, bromo group in bromoethane. We've just done this one. Gotta love it. Test, I'm going to add silver nitrate. This, by the way, this is a great one that I need to check the mark scheme on. Because as I said, you don't need the nitric acid because it's actually going to acidify itself in the process anyway, which will destroy any carbonate ions. I'll do that in the anion testing. Observation, I am going to get a cream precipitate. Cream, not green, cream. Sorry, I'm going to change that. Make it clearer. Cream PPT. I like it. I really wanted to. This is in May 24. By the way, guys, jumping straight on to have a look at a mark scheme. Let's have a look. Different question. Let's go back to here. May 24. This is a great website, by the way. Chembase LK past papers. Really nice paper. Let's have a look at where that question was on this paper. Let's see how long it takes me to find it. I just literally cropped them, guys. And I didn't take the mark scheme. There it is. So this is question number, ew, gross, right at the end too. 2G? Gross. 2J? Blimey. All right, there you go. 2J. Let's have a look and see if Mr. Duncan gets it right. 2J, please. Bring me 2J. 2I, 2J. Okay. Oh, let's have a look. That's interesting. So they wanted to add PCl5, misty white fumes. Do not allow reference to aqueous. Do not allow reference to smoke for fumes. See, I told you. Allow tests such as addition of sodium metal produces fizzing. Could have done that one. Orange to grease with the use of acidified potassium dichromate. Nailed it. That's really interesting. They wanted PCl5. So random. That's like my third test for an alcohol. Go figure. Last one. Add acidified. By the way, the brackets means it's not needed. That's interesting. Allow ethanolic. Oh, by the way, that's actually better. Ethanolic would actually be better because ethanolic means that the the aqueous layer and the oil layer will actually dissolve better. So ethanol is actually a better answer. So add silver nitrate, don't need the word solution, don't need acidified, forms a cream off-white precipitate. Nailed it. Always nice. Well, marked it straight away. By the way, I marked it because I honestly wasn't 100% sure. And I wanted to see all the different versions. So, by the way, I love the little bit of ethanolic, just like Mr. Duncan. I really like that addition. I'll do that next time. Ethanolic silver nitrate. Really like it. It dissolves better in the oil. Cool. Right, next one. They've given us this disgusting molecule and they've circled functional groups. So, everybody, you can pause the video and have a go at naming your functional groups now. Okay, functional group number 1. Pause it. It is a ketone. Yay, this is a ketone group because the C double bond O is in the middle of the chain. Yeah, we then have functional group number 2, an alkene group. Love it. Gotta love a good alkene. And I have a be careful on this one. This one requires detail. Don't get it wrong. It is a secondary alcohol. You can't just say alcohol. They would take it off you. Have to be a secondary alcohol because it's on the chain. Yeah, it's in the middle of the chain. It's not a tertiary. There are 2 carbons next door. Be careful. Okay, so name each of the functional group. Oh, nice. So the only one there that's going to cause any problems, by the way, is the secondary alcohol. I've got a third of my kids who will forget secondary. Describe the test. I'm going to fill this out anyway. Why not? Group number 1 is a ketone. Group number 2 is an alkene group. And the group number 3 was a secondary alcohol. That's the bit everyone's gonna miss. Okay, describe a kernel test and expected positive results for these functional groups. Number 2, alkene, bromine water. Test, bromine water. Observation. Yeah, obs. I'm gonna write down orange to colorless. Orange to colorless. Gotta love it. Solution. I like doing solution. Oh, blimey. So easy. RTFQ, read the question. Bromine water, result, orange to colorless. So easy to do. Don't get it wrong. If I'd done that in the exam, by the way, in pen, I'd just have written it again on the line. So anyway, bromine water, orange, because it works with number 2, your alkene group. Nice. Could have also done potassium permanganate, purple to colorless. Next, functional group number 3. Ooh, secondary alcohol. Let's use PCl5. Go for it. Why not? PCl5. I'd love to see if they actually followed it through as the one that they wanted. PCl5 should be anhydrous, really. Sure, anhydrous. That means without water, by the way. PCl5 reacts with water. Result, misty white fumes. I can't wait to look at the mark scheme to see if they wanted PCl5 as the top answer. Oh, shoot. What was it? The paper was Jan 24. Go to Jan 24, paper 3. God, which question? What? Nice. It's question number 1. That makes my life so much easier. Whoop, whoop. Let's have a look. Is it going to be PCl5? Secondary. Oh, damn it. They say you don't actually need it. That's really annoyed me. Ugh, ignore it. Mine's better. Functional group. There you go. Bromine water, Br aqueous. Result turns from orange to colorless. Perfect. Notice they don't need the orange, but you should do it. Just trust me on that one. Right, look at this one. I love Edexcel's inconsistencies. PCl5, top answer. Oh, they're doing sebacoyl chloride. Oh my God. No, sorry, that's not sebacoyl. That's thionyl chloride. Gross. SOCl2 and PCl3. Misty white fumes. Same observation, by the way. Don't learn that one. It's not on A level. Don't even know why it's there. PCl5. Misty fumes. Love it. Misty white fumes would be better. Ignore white smoke. Do not say smoke. It's not smoke, it's fumes. Test, sodium metal. Yay. We could, test, allow, acidified potassium dichromate. You could allow, and all of the above. Gotta love it. Misty fumes. Next, okay, separate samples of cyclo. Remember I said to you guys that cyclos can be on either. You can see what they're doing here. This is neat. Sample of cyclohexanol and cyclohexene. Tested with PCl5 and bromine water. Observation. So PCl5 with the alcohol is going to give me misty white fumes. See, by the way, this is why I teach it. Misty white fumes, not smoke fumes. Cyclohexane, no change. Nice. Bromine water, cyclohexanol, no change. This is easy, isn't it? Orange to colorless. Just trust me on this, folks. I just don't trust Edexcel. Just give me both colors. Cool. Okay. Could check it. October 23. I'm pretty secure on that one. I'm all right with that. Okay. Test is carried out. Okay. Test is carried out to identify two organic liquids, C and D. A small amount of PCl5 is added to each. C, misty fumes given off. D, misty fumes given off. Name the misty fumes. HCl. HCl gas. Gotta love it. Next. By the way, that could be an alcohol or it could be a carboxylic acid. Could be either. Next. Sodium carbonate. Oh, hello, carboxylic acid test. Fizzing. Lime water turns cloudy. Nothing. By identity, the formula of the gas produced. Identity, name or formula. Nice. I'm putting CO2. Keep it simple. CO2 gas. Nice. So, by the way, that tells me that C is a carboxylic acid and that D is an alcohol. Don't know if it's primary, secondary, or tertiary, but at least I know who they are. Right. Benedicts and failings, separate samples of each. The test tubes were placed in a warm bath. What? They're telling me that this could have been an aldehyde? That's strange. I mean, alcohols do oxidize in air to form the aldehyde. I don't like it. But anyway, guys, Benedict's or failings, which is the same test, copper 2 plus going to copper 1 oxide. It's the test for the aldehydes. C is given no because it's a carboxylic acid. We know what that one is. That one's easy. But the next one's going to be an aldehyde. Give the expected observation for a positive result. Oh, that's clever. Orange, red precipitate. Orange, red. Didn't even read the question. I was just starting down the rabbit hole of who are they. Oh my goodness, they haven't even asked me. What? Oh, it's so boring. So D is going to be interesting because failings won't react. Failings won't react with an alcohol. I mean, you could say that the copper 2 ions are going to. No, I don't disagree. That's interesting. It's telling me that D is a mixture of an alcohol and an aldehyde, which means, by the way, it's a primary alcohol. It's been left open to the air and it's oxidized to form the aldehyde. So there's a little bit in it. So that's kind of how it's working. Give a chemical test, including the expected result, and confirm the presence of bromine water. Okay, that's easy. There you go. Bromine water or acidified potassium dichromate. Either one. I'm going to go for bromine water. Gotta love it. Bromine water. That's French for water. And it goes from orange to gold. You see how often these come up, guys, right? This is fun. I'm enjoying this game. You can mark it for me, guys. There's the date. Have a look for it. Knock yourselves out. Nice. Student asked to identify organic liquid P and Q. I kind of want to do something that's a bit more, I don't know, bromine water decolorizes. Ooh. Oh, nice. Group Q is a group 1 halide, which produces a lilac flame in a flame test. Okay. So we've got potassium something. A few drops of potassium of nitric acid and aqueous silver nitrate, yellow precipitate. This is the iodide ion. Folks, this is going to come up in my next lesson. This is the iodide ion because of the yellow precipitate. We mentioned it before. Identify by name the ion present in Q. So the formula of the ions, so flame test is K1 plus by name or formula and I minus. Nice. Okay. When a few drops of dilute bromine water added to aqueous solution of pure red-brown precipitate forms. Of course it does, because we've got a displacement. In this, write the ionic equation. Nice. I minus is reacting with Br2. Bromine's more reactive to form Br minus plus iodine, which is red-brown in solution. Don't forget to balance the ionic equation. State symbols required include state symbols. This one's aqueous. Bromine water is aqueous. The Br minus is aqueous, and the iodine is aqueous. Nice. Gotta love it. The red-brown aqueous solution is formed. The mixture is shaken. Red-brown. We mentioned this, guys, with the test for the alkane group. So hang on a minute. They take organic liquid P, straight chain molecule with one functional group. It's an alkene, guys. It's an alkene shaken with bromine water. So we've got an alkene. 3 marks. Oh, I love it. It's going to go from colorless to purple, and then purple's going to fade. Oh, that's really neat. I need to see the mark scheme. That's lovely. That is really great chemistry. Guys, I've formed, so hang on a minute, is added to the red, but the mixture is shaken and allowed to stand for several minutes. State what the observation, including the changes in color. We're going to see 2 layers. Yeah, we're going to bullet point number 1. We're going to see two layers. 2 layers of liquid. 2 layers of liquid, the solution and the oil. We're then going to see that the organic layer will turn pink. Organic layer turn pink. Layer turn purple. Turn purple with iodine moving up. But then it's going to go through FRS in the presence of on standing. It's going to, in light, it's going to start to react and fade. Purple fade over time. That really, until it becomes colorless. Purple fade over time. Oh my God, I've got to see the mark scheme. That's like one of the best questions I've seen in ages. Alcohol, I don't really care about the rest. That's just like my favorite one so far. That's awesome. What paper was this? Holy moly. That's a lot of organic tests. This was in Jan 23. That's the only one I care about. Jan 23. Jan 23. Really? Let's have a look and see how long it takes me to find the question. Oh, first question straight off the bat. Color changing on shaken. That's it. Question number 1. That's awesome. Let's have a look. That's neat. So we've got, there you go, alkene. Name one, next one in, sure. Potassium, I didn't even do the first because I didn't really care. Balance the ionic equation, nice. State symbols, all aqueous, love it. 2 layers would form the organic liquid. The organic colorless layer will change to purple, stroke violet. And aqueous, damn it, missed one. The aqueous layer is going to turn colorless. Oh, I'm not going to get, except bottom layer will become, guys, that's how easy it is. Missed it. Now you see why I wanted to check my answer. You also realize, by the way, that, I'm not infallible. That was perfect. Bottom aqueous layer will lose its color. This layer becomes colorless. I need to star it. I forgot. Becomes colorless. I did it in my lesson and then totally missed it. The difference between lesson and question. Guys, I think I'm going to leave you there today. It has been a great long lesson. I didn't really mean it to be this long. Let's take away stop screen. Bring me back. Add camera. Have I added it? I have no. There. Hey, I'm there. 1 hour 25. Comments. Oh, let's have a look. Anyone else joined us? No, sir. Can you explain about partial pressure? I'll have to do a separate video. That'll be KP. I'm happy to do that later on. BM. I'll have a look into when I'm free. Guys, organic test completely boxed off. I will do inorganic next time. I'll see you guys soon.